Consider our earlier example of the company wishing to estimate the proportion of households with a digital television. How large a sample would the company need to take to be 95% confident that the error in using the sample proportion to estimate the true proportion is at most 4/100ths? If the company has no prior information on the proportion of households with a digital television. All right, the first thing that we have to do is we need to identify the confidence interval, or the C% value that we need for our confidence interval, which is 95% confidence. And with a 95% confidence, our critical value, or Z star, is going to be equal to 1n/9600ths. The next key piece of information that we can find from the problem is that the error in using the sample proportion to estimate the true proportion is at most 4/100ths, or 4%. And at most means that we have less than or equal to, and the 4/100ths represents our margin of error. And the inequality for the margin of error is the critical value, or Z star, times the square root of our sample proportion times 1 minus our sample proportion, all divided by n. Well, we're looking for n. We have the margin of error. We have our critical value, Z star, but we don't yet have our sample proportion, or p-value. So our effective guess for our sample proportion, or p-hat, is going to be 5/10ths, which is equivalent to 50%. So let's use this value for our sample proportion, p-hat, and the other values to determine what our n value is. So we're going to first substitute all these values in, solve the equation for n, and then substitute it into a calculator to find the answer. So our critical value, or Z star, is 1n/9600ths times the square root of our p-hat, or sample proportion, is 5/10ths, times 1 minus 5/10ths is going to give you 5/10ths also. So 5/10ths times 5/10ths, all divided by n. That's our unknown. And it's less than or equal to 4/100ths, or 4%. And now remember that the square root includes both the numerator and the denominator. So if we move n to the other side, we would have to multiply both sides by the square root of n. And we can move the 4/100ths to the other side by dividing both sides by 4/100ths. So when we do that and simplify, we'll end up getting that 1n/9600ths divided by 4/100ths times the square root of 5/10ths times 5/10ths is less than or equal to the square root of n. Now some of you might be saying, well 5/10ths times 5/10ths is 5/10ths squared, and I can square root that, and I'll have 5/10ths. So 1n/9600ths divided by 4/100ths times 1/2, or 5/10ths, is less than or equal to the square root of n. And then to get rid of the square root, we have to square both sides. So we're going to have 1n/9600ths divided by 4/100ths squared times 5/10ths, or 1/2 squared, and that's less than or equal to n. And if we substitute this into a calculator, we'll end up getting 625/100ths. And we have answers here So I'll write it down in here, greater than or equal to 625 hundredths. So the at most is definitely not correct because n has to be greater than or equal to. That means at least. But now the question is, does 600 work or do we have to go to 601? So let's check to see if 600 would indeed give us a confidence interval within 4% of 50%. So if we substitute the n value of 600 into our formula to determine the confidence interval, we end up getting 54%, and all of these 9s in a row will round this up to 46%. So 600 would give us the required n value needed to get within 4% of our data. So the correct answer here, or within 4% of our true proportion. The answer here is C, at least 600.